Welcome to section 5.5, part 2. Now we're doing right triangle applications. In the previous video, we just mainly talked about SOHCAHTOA, making those ratios using that information. In this video, we are talking about how to address applications. So let's look. In this particular video, I've pretty much just copied and pasted some of the homework and talked about how we can create a triangle from the words. It's not really that difficult. It's not really any different from anything else that we've done. So let's get started. In this first question, it says, a 34-foot ladder leans against a building. So let's see. Here's our building right there, and the ladder leans against the building. So we've got this. Might as well make it look a little bit like a ladder, right? There it is. And what do we know about that ladder? It's 34 feet. 34-foot ladder leans against a building so that the angle between the ground and the ladder is 83 degrees. So I did not do a good job of making this to scale, but the beautiful thing is these things don't really need to be to scale in order to work. So I'm always thinking first about what my right angles are. So there's that. And the angle between the ground and the ladder is 83 degrees. So this angle is 83 degrees. Basically, that means that this angle up here is 7 degrees because 83 plus 7 is 90, plus another 90 would be 180 degrees. The angles of a triangle have to all add up to 180 degrees. And then the question is, how high does the ladder reach the building? How high does the ladder reach the building? That would be this. I'm going to call it X. So let's talk about this. I'm going to use the 83 degrees because that's what was given in the problem. And if I do, then this guy over here that I want is the opposite side, right? That's opposite. And then the other piece that I have is the hypotenuse, 34, opposite the right angle. So I've got the opposite and the hypotenuse. So, SOHCAHTOA, so the sine is equal to the opposite over the hypotenuse. The sine of the angle, I'm going to use theta to represent an angle, is the opposite over the hypotenuse. So that's what I'll do from there. That means that the sine of 83 degrees is equal to the opposite leg, x, over the hypotenuse, 34. In the last video, we talked about how to solve those, so we are not going to do that here. Let's go on to the next example. The angle of elevation to the top of a building in New York is found to be 7 degrees from the ground. Okay, so hold on a second. Here's the ground. And then the angle of elevation to the top of the building. So here's the building. Right here. Make a little window. Okay, so the angle of elevation to the top of the building, that would be this angle right here. 7 degrees from the ground at a distance of 1 mile from the base of the building. So that means that this particular distance, wait a minute, that didn't turn out like I thought. That means that this distance is 1 mile. Right there. So 1 mile Oh, they want it in feet, though. I'm going to call it 5,280 feet. What do they want to know? Find the height of the building. Height of the building, right here, is x. So I've got, from 7 degrees, I've got the opposite of the angle 7 degrees, and I again have, what is this? This is opposite. Here's the 90-degree angle. So this guy is the adjacent leg. So I've got the opposite leg and the adjacent leg. What trig function am I going to use? OA, opposite over adjacent. The tangent of 7 degrees is equal to the opposite, x, over the adjacent, 5,280 feet. All right, one more example to do. A radio tower is located 400 feet from a building. Okay, here we go. Let's put the building on the right again. Here's that. A radio tower. I don't know. What does that look like? This. No idea. There's the tower. 400 feet. They're 400 feet apart. Here's that, 400 feet. Can you tell I didn't review these first? It's okay. It'll all work out, hopefully. From a window in the building, oh, look at that. I drew a window. A person determines that the angle of elevation, oh, I did this wrong. Well, that, or I think I'm going to make this tower a little bigger, because if there's going to be an angle of elevation, it means that I have to look up to see the tower. So let's see. Let's make this tower up here. Right there. Okay, so, and then I'm also going to make this window right there. So from the window, this person is looking to the top of the tower. And it says, from an angle in the building, a person determines that the angle of elevation to the top of the tower is 25 degrees. Now keep in mind that an angle of elevation goes from a straight distance. Okay? So that means that this, that this angle is 25 degrees to the top of the tower. The angle of depression to the bottom of the tower is 23 degrees. So an angle of depression, this is such a great example. Right down there, that is 23 degrees. How tall is the tower? What we have here is a great example of two triangles that we need to use in order to solve this. I am going to call this distance x and this distance y. Okay, also keep in mind that at the bottom here, I've got this triangle where I've got, well, actually I could make it here. Let's just do it here. Then I don't have to explain all of that. So what we have is the triangle below. It's the right triangle below. We've got this 23 degrees, and this is 400. Remember, if that distance down below is 400, that means that this distance, of course, is also 400. So 23 degrees, I want this. I've called it y. What trig function am I using? You got it. I got the opposite and the adjacent. I'm going using the tangent of 23 degrees is the opposite leg over the adjacent leg, 400. And then for the other triangle, which I've got right here, I am also going to use the tangent function. How do we do it here? The tangent of 25 degrees is equal to the opposite. Opposite is x. Adjacent is 400. My final answer will be x plus y, whatever that is. Please let me know if you have any questions. Do not struggle on your own. I'm happy to meet with you and answer all your questions.